not so far in the future, filled with innovation, Juan is planning the first ever interplanetary games.
The very first interplanetary games! Yay!
Finally!
We'll get every planet involved.
And send invites to their athletes.
Okay, great ideas, team. Hey, Oracle, create a scheduling app to coordinate the interplanetary games. Excellent. Send invites to all eligible athletes in our database.
Let the games begin.
Hey, Oracle, generate an app to analyze attendee engagement, ad revenue, and total spend.
Congratulations to all our winners.
Hey, Oracle, make me an app to set up athlete meet and greets. Hey, Oracle, thank you.
Please welcome to the stage Juan Loaiza.
All right. Hey, everyone. So we're going to learn how to build that app today. So get ready. So that's kind of what we want the future of data dev and app dev to look like. You say what you want the app to do, and then the AI generates the app. That's kind of the future, but how realistic is it for real? Really, it's not terribly realistic because AI can't really generate a complex app. It's nowhere near capable of doing that. And at present, the main way that developers use AI for enterprise apps is to accelerate the current development processes that they already have by generating kind of a medium amount of code for well-defined tasks. And this is what everyone is doing today. And the question is, can we scale what we're doing today up so that it can build enterprise apps? And in some ways, yes, in some ways, no, because very soon it's going to be possible for an AI to generate the volume of code needed for an enterprise app, which is going to be an order of magnitude faster than humans writing the code. But it's not really a viable way to create enterprise app. And that's really what we're going to talk about today. Because you can't really bet the business on thousands of lines of AI-generated code that no human being comprehends. So you have to really be certain that enterprise apps are correct, understandable, and dependent. So this isn't going to work. So what I'm going to talk about today is kind of a strategy that is much more possible to work. And an important thing to keep in mind is that revolutionary technologies like AI, and AI is a revolutionary technologies, they require changing the way we do things. And the analogy I use is that you don't get the full benefits of cars by replacing horses. You had to create car-centric infrastructure like paved roads to get the real benefits. And using AI to accelerate code generation without changing the development infrastructure is a lot like driving a race car on a horse trail. So we're going to have to change the infrastructure in order to get the real benefits from AI. And that's primarily what I'm talking about today. So enterprise app development infrastructure suffers from like 3 main issues that are going to limit the benefits of AI. So the first issue is that there's widespread dependencies and assumptions within the apps that make generation and evolution difficult. As long as the apps are kind of interlocked together, it's hard for an AI to come in and generate something new. Second issue, the volume of code. So enterprise apps are huge. The volume of code, of how generated code, how oriented code to make an app work, an enterprise app work, makes the app really hard to understand, verify, and maintain. And then third, enterprise-grade robustness has to be coded pervasively throughout the app. So these things are kind of like the dirt road that's going to prevent AI from really achieving what it can achieve. And so what we really need is AI-centric enterprise development infrastructure. And that's primarily what I'm going to talk about today. I'm not going to talk about how AI, LLMs are going to magically solve every problem in the world. I'm going to talk about realistic, practical ways to get AI to really help with enterprise apps. Okay, so what we need really is infrastructure that facilitates AI development, that enables apps to be generated as a collection of independent, trusted, and evolvable modules. And also, that makes generated apps understandable and editable by emphasizing concise, declarative languages that say what you want done rather than how to do it. And third, that automates the scalability, reliability, consistency, and security needs of enterprise apps. You can't just depend on AI to generate all this stuff for you and get it all right. So that's primarily what we're talking about today. Okay, and what I'm going to talk about today is a methodology and a technology that we've developed that meets these needs. And we call this Generative Development for Enterprise, or GenDev. And what GenDev is a groundbreaking AI-centric development infrastructure that we've introduced with our latest generation of our database, Database 23 AI, to accelerate the benefits of any AI and mitigate the risks. So this is independent of the LLM that you use. This is really useful. It's the infrastructure around the AI that we're talking about. Okay, so GenDev is going to enable developers assisted by AI to generate, to innovate at light speed. And the way it's going to do that is by focusing their efforts on building app functionality rather than being preoccupied with infrastructure needs. And at first, I'm going to talk about data, because data is the core of enterprise apps. So data is the core of GenDev. Okay, so the way I'm going to do this, I'm going to walk through this thing that we saw at the beginning, which is this interplanetary games app. So to understand GenDev, I'm going to walk you through how you create an app to manage these future interplanetary games, which is the next thing after the Olympics. All right, so let's get started with the example here. So the interplanetary games app is going to have three main modules, right? So one that manages athletes, second that manages events, and the third that manages the attendees. So those are kind of three big parts of something like this. And GenDev modules are highly independent. That's the real goal. We want to make all these modules independent from each other, because that's going to greatly simplify the module design and implementation and generation. And then this is a key thing. We want each app module to be built using the data representation and data access API that's best for that module, because we don't want to compromise the representation of a module to satisfy the rest of the modules. That breaks this whole independence. Again, the goal is we want to look at each module, have AI generate each one independently without all these interlocks with everything else, which is going to complicate things, and we're not going to get it right. Okay, so the first step in GenDev is pretty simple. You say, okay, I have these three modules. What is the data that each module independently needs? So looking at each module independently, what data do you need? Well, okay, when we're talking about athletes, you need the athlete name, where the athlete comes from. Since it's in interplanetary games, you need to know the athlete planet and region. And you need to know what events the athlete is participating in. So the event title, the sport, the location, and the time. Okay, now for the events, again, you need the event title, you need the sport, the location, the time, the description, and then you need the list of athletes in that event. Who are all the athletes participating? Where are they from? And then you need all the attendees, right? Who is attending this event? Where are they sitting? What are they doing? And then finally, for attendees, again, it's pretty basic stuff. The attendee name, where the attendee comes from, the planet and region, contact information, payment information, that kind of stuff. And then the schedule. That attendee, what events are they going to attend, at what time, in what location, where are they sitting, all that kind of stuff. So this is the app that we're going to build. And so this is the key thing. You just say, hey, what data does each app independently need? Okay, got that. Here we go. So how do we want to build these modules? Well, the ideal thing is for each module to simply be able to read or write the exact data that it wants as a simple JSON document containing exactly the data that it needs. So the thing that I described in the last page. So for example, for the athlete, we want to be able to say, hey, what's Emma's data, athlete Emma? Well, it's what I described in the last page. You want the name, the planet, the region, the schedule for the athlete, all that kind of stuff. And you want to be able to just read and write that from the database so that that athlete module says, hey, give me the data for this athlete. It can edit it, and it can write it back to the database. So that's the simplest possible data interface for the athlete module of this app. So that's the goal, okay? Now, it seems like, hey, I'm just putting and getting a JSON document, so that's a natural fit for a JSON database, right? Because you can just put and get JSON documents. But JSON databases can't really do this because they don't support shared data. So if you look at that, the part that's in the red bar, that event information, what's the event name, where is the event, what time is the event, that's shared across a lot of athletes, across the event, and across the attendees. They all have this information. So if you just put this as a single JSON document, what happens is you get duplicate copies of this spread all over the place, and every attendee and every athlete. So this is bad. So that's going to be a big problem. Why is it a problem? Well, it's pretty simple, because if that data ever changes, the developer has to go and update it everywhere, in every athlete, and every attendee, in the event, everywhere. And that breaks the independence of apps. So for example, if you're the event module and you want to change the time, suddenly you have to know about every athlete, you have to know about every attendee. So there goes your app independence out the window. And also, it's difficult and inefficient to keep all this duplicate data. So JSON databases don't really do a good job with this, and neither do relational databases. So we need something a little different to create this app independence. Now, when we talk about this, what the usual thing people say is like, oh, the problem is you've copied this data everywhere. So instead, I'll separate that event data into a separate document and then put a reference to it everywhere. So that sounds good. That sounds like it solves the problem, right? The trouble is, the workaround requires each of the modules to figure out what's shared data so I can break it out. So again, you've broken the independence from other modules. You have to know what data other modules are doing so you can break that out. And then as new modules or new use cases get added, you get more shared data that you never anticipated. So trying to anticipate and work around these things doesn't really work. That's one of the problems with enterprise apps is as they get more complex, you have to share more data, it gets more complicated. All right, so this is something that we've been working on for a long time. We've been thinking about, because this is a fundamental problem in database systems, right? And so what we've done is we've addressed the root cause of these cross-module dependency issues using a unique approach. What we're doing is we're saying, hey, let's separate the access format, how the app accesses data, from how the app stores data. So that's kind of a key insight. The way you access the data doesn't have to be the same way you store the data, right? And today, that's kind of the case. So if you look at a JSON database, the way you access the data, you get a JSON document, it's stored as the same JSON document. Same thing really is true for relational. You store the data in tables, then you access the data from the tables. You have to break these things apart. That's really the key. We want to allow each module to declare exactly the API, the data API that it wants, unconstrained by the storage or what any other module wants. All right, so what we do in GenDev is we say, first of all, we're going to break the data up so that it stores each independent piece of data exactly once as a row in the table. And all the relationships with the data, the many-to-many relationships, are also stored independently in rows in a table. So that prevents all this duplication that's going on. Now, this is something that we've actually known about for a long time. Storing all this independent data exactly once is called normalization. And that's the foundation of the relational model. That's why the relational model was invented, because normalization eliminates all this data duplication and its pitfalls. Right? So that seems like a good idea. Then you get the problem of how do you generate all these tables? So I have this data that I want in each module. First step is I got to generate the tables to store all this, and then we'll get back to the API. So how can we generate the tables? How do we know what tables to create? Well, Chris Rice is going to show us. He's going to show us a demo of how AI can make it easy to generate this normalized interplanetary games table, starting from their high-level descriptions, which is what I talked about earlier.
Here, we're in Database Actions or SQL Developer Web. We're going to go ahead and launch our new AI Assist. In this AI Assist, we're going to go ahead and give it a prompt. And in this prompt, we're going to outline exactly what we want. We're going to outline that we want event storage with their times, the sport, the location. We're going to tell it that we want our athletes, including their names, their home planets, and the attendees and what events they're attending, along with their credit cards and scheduled events. Then we're also going to ask for 10 minimally rows of sample data for this same schema. The other thing that went across in this request was that our guidelines for what we like our SQL to be formatted like, what we want our primary keys to look like. So what we can do is bring this over into our worksheet where we can review the SQL that came back, review the DDL. We can check that our primary keys are correct. We can check that our foreign keys are correct, our triggers, our indexes. We can basically review everything to ensure that it is exactly what we wanted and what we requested, or if we had to make any alterations. Then we're able to run this script and create these tables in the local database, where we'll interrogate very quickly and ensure that our athletes came over, as well as a couple sample rows of data.
All right, great. So again, we're building these modules. First thing we do is we define the modules. We say what data you need. Chris just showed us with AI, we can now generate the table structure that we need. But that's not really the final goal. What we really want to do is create this API on top of it for each of the modules. So GenDev enables each app module to use its preferred JSON format to access data that's stored in these normalized tables. So the way this is going to work is when an app module requests a JSON document, like when we request that Emma athlete module, the database is automatically going to generate that JSON document from the underlying tables. And when it changes it and writes it back, it's going to take that JSON document, write it back into the normalized tables. So this is going to provide us the simplicity of JSON with the data integrity of relational, and makes it super easy to use. So that's the big picture of what's going to happen. Okay, now we said, hey, we want this JSON document, we want these tables. How do we know how to translate the JSON document into these normalized rows in these tables? Well, that's something new in Oracle Database 23a. It's called the JSON Relational Duality View that defines this mapping. And you can see the mapping here. So this thing on the right basically is the view, which is a new kind of view that we've introduced, which is a view that maps relational data into JSON data and back, so you can read it and write it. And it's very simple to write these views. You can see there, you say create the duality view, and all it's really doing is specifying which tables and columns each key value pair in the JSON document comes from. So the green stuff is coming from the athlete table, the yellow stuff is coming from the relationship table, and the red stuff is coming from the event table. So it's very simple to create these views, and it uses GraphQL syntax, which most developers now it's a very common format that most developers are aware of and are very familiar with. So it makes it very simple to create this mapping. And that's all you have to do. Suddenly you've created this duality view for an athlete, and now that creates the API that the athlete module wants. Now, again, Chris Rice is going to demonstrate using SQL Developer and VSCode how we can generate this JSON relational duality views without even knowing any of the syntax, just by knowing what data you wanted in.
Now we're in SQL Developer for VS Code. We're going to go ahead and connect to the same database we just created a set of relational tables to store our data and generate a duality view. We're going to launch our duality view builder, which allows us to graphically design and alter the structure of this duality view while having the actual DDL syntax generated for us. The goal is to represent in a duality view the athletes and their schedules. So we're going to add the 3 tables we need for athletes and their schedules: the athletes, athlete events, and the events. As we add the tables, we can go ahead and alias the tables off to not expose the direct table name, but simply a friendlier name. Then we can go ahead and start picking off which columns we would like to expose in this duality view, taking note that the middle table, the intersection table, does not actually get exposed in the duality view, except by being an array of the children. As we're doing this, we can see at the bottom our GraphQL syntax is being generated. We can see our structure on the right-hand side. We can go ahead and test our query to ensure the structure represents what we expected it to be. Then we can finally go ahead and create this duality view. Once this view is created, we can verify it existed, and we can give it to our developers to start accessing this relational data through duality.
Okay, so again, we've broken this app into modules. We've said what data each module needs independently. We used AI to generate the underlying tables. And now we've created these views that create the JSON structures. He showed you how to do it visually. You can also get AI to help generate that, or you can type it yourself because it's really not that complicated. So this is a big deal. This JSON relational duality is a very big deal. This is, I think, one of the biggest breakthroughs in data management years. I've been working on this thing for decades, and it sounds very simple, but the ability to map these things back and forth, and particularly the writes, is actually quite sophisticated. It requires a lot of sophisticated underlying technology, but we've made it very simple for users. And you can see here that Carl Olofsson from IDC says the same kind of thing. He says, Oracle's JSON relational duality is perhaps one of the most important innovations in information science in 20 years. There's a new technology that we're introducing in 23i that's going to make developing these apps dramatically simpler, give developers a very simple access format, exactly what they want. Now, customers are already using duality views to make it easier for apps to access data the exact way that they want to. And I'm going to bring to the stage Akash Guha from PayPal, who's going to talk about how they plan to use duality views. So please welcome Akash.
PayPal has been revolutionizing commerce globally for more than 25 years, creating innovative experiences that make selling, shopping, and moving money more secure, personalized, and simple. PayPal empowers consumers and businesses in approximately 200 markets to join and thrive in the global economy. Please welcome to the stage Akash Guha.
All right, hi, Akash. Thanks for joining me today.
Thanks for having me here.
Great. So maybe you can start by just telling us a little bit about your role at PayPal and what you do.
Sure. So I lead the team which manages PayPal's online transaction data systems. So PayPal today serves traffic for 400 million consumer accounts and about tens of millions of merchants in 200 plus global markets. So we operate our databases with extreme scale. We manage hundreds of petabytes of data and trillion transactions on our peak traffic day. So, and on top of that, because we are fintech, we have to operate with extreme security. So the majority of this data flows through Exadata, and I want to thank Oracle for our partnership in this. I've spent 14 years in PayPal today, and I always promoted a constant scale bottleneck awareness for us. And how do we proactively mitigate these bottlenecks before the system fails? Prior to PayPal, I have also managed databases for Gap Online and Cisco, where my focus is how to improve the availability of these databases, which are deployed with rack architecture.
All right. Well, that's great. Maybe you could tell us a little bit about the data challenges that you're facing at PayPal.
Sure. First, data is like the lifeblood today. It is driving all your decision makings, your innovations. And on top of that, it is helping companies like PayPal, it helps us to connect to our customers. So organization, whether it's small or big, doesn't matter. Everybody wants to acquire more and more data, right? It is growing exponentially. On the other hand, if you look at applications, they're also evolving due to the sophisticated need of your business requirements. So in doing so, the data is taking different forms. In some cases, microservices, they are really favor key value document data stores. Whereas when it comes to complex queries, you are storing the same data into relational format, right? The burden of mapping this data between unstructured and structured is falling on the application. And this challenge is what is leading to is the application delivery timelines are impacted. I think today we are in the crossroads of this abundance of data and the complexity of the data models, which we have to think through how we can reshape this entire approach.
Yeah. And so you learned about JSON relational duality, probably about a year ago or so. Mm-hmm. So what are you thinking? How could it help you improve your development agility at PayPal?
Sure. I think the problems I stated, it does address some of those. I like the fact that it avoids data duplications. As I said, like microservices, they love to query document data in a JSON format because they can get everything in the entirety. Whereas with JSON model, we can also have secondary key lookups, which can help for complex queries as well. And there is very minimal performance impact on that. On the top of that, it is shielding the developers from managing this complexity of data mapping between unstructured and structured systems, which is a big win. But I believe JSON duality would be very popular within the developer community. And we can leverage both the key value document model plus the relational model that will drive our next generation of applications.
Yeah, it sounds great. So you've also been looking at some of the other Oracle Database 23a technologies. Anything particularly interesting you're looking at?
Quite a few. First of all, we are in the breakthrough of technology, the age of AI, right? AI is everywhere. Like today, as I said, our decision making, whether it is related to new feature or what personalization for our customers, everything is AI driven. So we are very excited about the vector capability in 23i, because I believe that will really help by real-time data feed to help us to personalize that experience for our customers. And also, if you think for our merchants, that is a huge benefit, because now they can actually use our services to use the data that we capture and present it to their customers and have them a better value propositions. I think with Oracle's reputation, with the scale that you can operate and the concurrency that you can manage, I think it will scale pretty well in OLTP systems. Other than that, we are also looking into a true cache, because cache is always mostly as a key value concept, right? And the data you have to read from the databases. Now think about application maintaining the data consistency between these two. True cache is helping to manage the data consistency between the database and the burden of mapping again the document model plus the relationship is now on the database itself. They don't have to maintain it anymore. I think it is pretty exciting, and it will drive the agility as well. Lastly, I myself is pretty excited on your newly distributed database with Raft replication. So far we have been very successful in scaling our reads. We have created read replicas, and whenever we do any maintenance, we just have to move the reads without any problem. But for writes, it has been always a challenge, because when you are moving from one cluster to another, you have to make sure that data is synced up, there is no data loss, and then only you can move the writes to the other side. JSON duality, the Raft technology will now allow you to seamlessly fail over the writes within just few seconds. For companies like us, which is operating 24/7, I think that's a great win for us. So overall, 23AI, I see it will drive the applications to be more responsive, more predictive, and definitely more reliable.
Yeah, it's a lot of very cool technologies, and I think your customers look very deeply at it, and we're going to see a lot of use for these things. These are technologies we've been working on for years, so it's nice to see the customers like you looking to adopt this technology, because it's genuinely useful, right?
Absolutely, looking forward.
Breakthrough, and it's useful.
Yes.
Okay, great, Akash. Hey, thanks for joining me today. Appreciate it.
Thank you.
So again, we've talked about this duality concept, JSON, relational, they're kind of the same thing. This is really the cornerstone of a very large effort that we've had at Oracle in this latest release to unify the relational, document, and graph models. Because the database world has been kind of fracturing into these worlds, right? There's people that want to do just JSON, people that want to do relational, people want to do graph. And what we're trying to do is reunify all these things so you can get the best of each of those at the same time against the same data. So that's really been our goal, and we've come a long way in Oracle 23 AI. As an example of this, we talked about duality views. Well, when you create a duality view, it automatically generates a REST API and the Mongo API to get or put the data in JSON. So it gives that REST API automatically. So you say, each module says, this is the JSON document I want, you get the REST API. Obviously, you can still run SQL on the underlying table. So an example of this is to analyze the popularity of each sport. There's lots of stuff that you could do with SQL against the exact same data. And then, in addition to that, we've added a graph access to the exact same data. So recently, there's an ISO standard that we pioneered called SQL PGQ that's been implemented in 23 AI also. And that lets you query data, the exact same table data, as if it's a graph with very high performance. So you get the best of all these worlds. You get the best of JSON, SQL, and relational all against the same data. Again, we think this is the future of data management. Everyone's going to end up doing this. The idea of having specialized databases for each data type kind of doesn't make sense because every app wants different things. For some use cases, it wants to see the data as relational. For other use cases, as a graph, and for other use cases, as JSON. So this is going to be the future of the entire industry very soon. All right. So that's kind of the first topic. So we've seen how GenDev facilitates this thing, the module independence. Each module defines the exact API that it wants. It gets the interface that it wants. So that's really great, and that's really transformational for the entire industry. And also, we talked about how we've unified all these models. So now let's move on to discuss kind of automating all these enterprise necessities, things like confidentiality, consistency, data evolution, and generatability. That's a hard word to say. Generatability needed for enterprise apps. Again, the big picture is if we want to have AI help us generate apps, every module can't have to worry about confidentiality, consistency. It can't be built into the code for every module. That's not going to work. That's not going to give us the agility and the correctness that we need. Okay, so let's start with confidentiality. So everyone knows confidentiality is important. If you breach confidentiality, you get fines, brain damage. You can even go to jail for breaching confidentiality. So as a simple example in this interplanetary games app, we might want each of the attendees to be allowed to see, obviously, their data, but not other attendees' data. But, and this is an interesting example, you might say, hey, people that are in the same family or my friends, I want them to see where my seating information is. The people at each event, the officials need to find out where everyone's sitting. So you have a little bit more complex than just saying, me, I can only see my data. And this is real world. When you're talking about financial data, when you're talking about medical data, if you're the parent, you get to see your children's data, but you don't get to see other people's data. So what we've done in GenDev is to allow confidentiality rules to be declaratively specified and enforced. So the way this works is that GenDev can filter data based on the current user of the app. So if you're a specific user, the database will enforce that you can only see your data, and in this example, your family's data. So we use various features in the database. We have something called virtual private database. We have something called label security. And the most advanced feature is called real application security. And the idea is simple. Based on each user, the database only gives the data that user is supposed to see. So the app modules don't have to worry about this stuff and can't get it wrong because each app module can only see the authorized data for that particular user. And again, this is a big deal. Data confidentiality is automatically enforced by the database without having to flawlessly implement it in every generated access or SQL. The way this relates to the whole AI thing is when AI generates some module, how do you know that it's going to get all these confidentiality rules right? In theory, you could check it all, but in fact, as AI gets better and better, people are going to stop checking, and then we're going to end up with a confidentiality breach. So it's much better to just build it into the infrastructure, have it declaratively specified and enforced. Okay, now let's move on to data consistency. So again, enterprise data has to remain consistent despite a high concurrency by a lot of other users. So what are some of the issues that we've had for this? In this Games app, we want to allow attendees, for example, to take as much time as they need while they're looking at their schedule, editing their schedule, and we don't want to hold locks that lock out other users. So this is a long-standing problem in data management. The only way to keep data consistent is to lock it, but when you lock it, you lock other users out. So we built a new technology into Database 23 AI that uniquely provides something we call value-based concurrency control to achieve consistency without holding locks. And the way this works conceptually is very simple. When you read data, you look at it, and if you write it back, what we do is we check that the data has not changed between the time you read it and you wrote it back. And the way we do that is pretty simple. We look at the values when you read it, we look at the current values, we atomically compare them and say, hey, has it changed or not? If it's changed, we'll just cancel the operation. So while during that human think time, which can be seconds or minutes, we're not holding locks. So it's not blocking anybody out, but it enforces the consistency. You can't overwrite data while you were looking and editing at the data. So this is a very new consistency algorithm that's never existed before that solves this problem of maintaining consistency without holding locks. And again, this is something that customers have come to us for years and said, hey, this lock holding thing doesn't work well for me. So this new value-based concurrency control solves a lot of these problems. The one that I just talked about was not locking data during human think time. But there's other issues also, things like mobile apps that want to write data while they're disconnected, mid-tier caches we talked about. How do you keep them consistent? Because whatever locks the mid-tier cache takes isn't going to affect the backend database. So it loses consistency. Also, data replicas. A lot of enterprises are now replicating data. How do you read data and write it back if the data might have changed in a data replica in the middle time? So this is a big deal. Again, this is a transformational change in the industry that really solves a lot of problems that have existed for years. And again, the Gen AI can't solve these problems. It wants to just treat the database as a black box. Okay, so that's data consistency. Let's talk about data evolution. So enterprise data needs to evolve to meet new needs without breaking existing apps. So this is a very big deal. Enterprise apps are always changing, and you can't atomically change the entire app. There's no way. That really slows down agility, and you want the teams to be able to work independently. So you need to evolve the data without having to change everything that exists. Now, there's a kind of a simple case here that works great today, which is what I call additive data evolution. So like JSON databases, GenDev allows new key value pairs to be added to a JSON access document without changing the backend schema. So for example, that athlete module, if you wanted to add something about the athlete's like allergies, you can just do that. You just write it into the JSON document, send it to the database will store it. That's easy. And same thing with relational tables. You can add columns, no problem. Anytime you want, you can add column. It doesn't affect any other module. Now, the hard part has been making non-disruptive modifications to existing data structures. That's the problem that everyone has been challenged with. And this idea of, well, here, the example the simple example is, hey, I said there was one planet that, one location that each attendee came from. Well, suppose you're married to somebody else from a different place. You want to know about both the athletes from both those planets. So a simple change like that, changing a single value to multiple values, that kind of simple change has been a challenge in the industry. Why? Because when an app is expecting a single value, you can't hand it a list of values or an array of values. That breaks the app. Okay, so very simple problem that's challenged the entire data management industry for decades. So this idea that we have is we can change the underlying formats and hide it from existing apps. And how do we do this? Using the same views that we talked about before. So relational databases have views, but they can't hide this kind of change. So the idea is you can create a JSON duality view, that view that we talked about, that's compatible with the old apps, but reads the new data schema. And then you have a new view that the new updated apps can access. So it's very straightforward, but you need that extra layer of abstraction between the application and the data in order to make this happen. So again, very straightforward conceptually, but this is a problem that's challenged the data management industry for decades. And this concept of duality views, it's a lot like microservices for data, because microservices basically provide independence and evolution by only exposing APIs. So you only access data through these APIs. And that's exactly what duality views, they automatically generate the APIs. But duality views go farther. As I discussed, duality views not only provide an API, but they allow declarative evolution. So you can declare a new duality view and evolve your underlying data. And the other thing that I talked about is they also provide ACID consistency for shared data. So when you're sharing data across modules, they'll atomically update the data, so you don't have to know about any other module. So it's a little bit like what I call an ACID microservice for data. And this can be used to replace microservices in some cases. For simpler apps, you can entirely use these duality view APIs instead of microservices. For more complex apps, you can collapse some of the microservices and make them more mini services, which makes application development a lot easier. So again, this is a big deal. It's kind of microservices for data with APIs that are transactionally consistent, ACID consistent, that you can declaratively evolve. Okay. Let's talk about AI generation. So enterprise schemas are complicated. They involve hundreds, thousands of tables, lots of columns, and it's very difficult to understand real enterprise schemas. So what AI does, you give it the schema, and it tries to help you generate things like SQL or procedures, but it has to understand the schema. And what it does, it just looks at the names and things like that and tries to infer what they are. That works some of the time, but it doesn't work all the time. So if we really want to enable AI, what we need to do is have a way of declaring the intent for the data. So the example I use is, suppose you have a numerical field that's called PC, right? And you hand that to the AI and say, hey, help me generate a SQL statement on this, or help me generate a procedure on this. It has no idea what PC means, right? PC could be a personal computer, it could be private and confidential, or it could be a payment card. So what we've added in our new release 23i is ability to declare the intent of something. So you have that field that's called PC, now we can declare this is actually a payment card. And the AI or applications can query that intent and then take action based on that intent. So it sees the PC, but it also sees an annotation that says this is a payment card. And so when a user says, hey, generate a SQL statement that lets me access all the payment cards, it can do that because it knows that it's a payment card. Also, we can automatically generate GUIs, a GUI that's appropriate for a payment card, because the application generators know that it's a payment card, not just some random number. So again, this is a big deal. This is really going to enable AI generation of applications, and developers can now annotate to generate. So again, a big deal. Okay, so taking a step back, the big picture is that we're in an era where AI can generate apps in seconds or minutes, but let's say it did that, how useful is it without the right infrastructure? How useful is having AI generate a bunch of modules that are tightly interconnected and intertwined, and that don't really work together? How useful is it to generate code that's so large and complex that humans can't really understand it? And how useful are generated modules that don't have these enterprise-grade robustness that we talked about? It's really not very useful. We have to change the infrastructure so that to enable AI to actually generate these apps effectively. And that's what this GenDev technology that we've talked about is. What it is AI-centric declarative infrastructure. So you say what you want, what confidentiality you want, what privacy you want, what kind of atomicity you want. You declare the independence. You declare each module independently. It provides the isolation. It provides the consistency, evolution, and generatability that you need for enterprise apps. And all these things, automating this has been a long-standing industry goal that's finally been achieved in Database 23i. So this is stuff that we've been trying to do for decades. And we've finally achieved this. We've kind of broken the code in 23ai. So now developers, just regular developers developing apps, and AI can focus on the app functionality instead of all this app infrastructure. So again, every single one of these things is a big deal for data management. And you put them all together, it's a gigantic transformation in how we're going to use data in the future to develop apps. Okay, so now we're going to transition to talk about how GenDev helps generate the application itself, because this is another big area that we're working on. So every app framework in the world is adding AI generation support. And all this GenDev infrastructure that I just described is going to be very useful for any of these dev frameworks, because all the dev frameworks benefit from the module independence, the automation, and the enterprise robustness. What we at Oracle, particularly in the database group, are focused on these days is low code. And that's what I'm going to focus on today, low code. Why? Because low code is an application development style that's becoming increasingly popular because creating apps using low-code's visual tools is faster, easier, more secure, and more concise than writing code. So this is what we talked about. Larry talked about this earlier. Apex, that's our low-code tool that we've been working on. Now the trouble with low-code is it's been primarily kind of aimed at simple apps. And the challenge for low-code is generating complex enterprise-grade apps. And that's what we've been working on with Apex for over 20 years. And that's what we're using now at Oracle to develop all our industry applications, a lot of our horizontal applications. That's our new way of developing applications. Okay, and what's interesting about Apex? What's interesting about Apex is its focus on these enterprise needs. It uniquely delivers low code without limitations, without the limitations other products have on the sophistication of that. You can generate an arbitrarily complex app on mission criticality. When you write an Apex app, it's mission critical out of the box on the number of users, on the interoperability with existing apps. That's a big deal. A lot of low code is kind of a closed environment. It doesn't interoperate with anything else. I would also add that Apex is completely free. So it's provided by Oracle for no charge on any of these things, on users, on complexity, on anything. And today, over 3 million Apex apps exist, and thousands of new Apex apps are being generated every day. Now, what's new here? Apex, we've introduced now something I'm calling Apex GenDev, which is a new AI-centric version of Apex. So we're bringing Apex into the AI world. So Apex GenDev uses something called blueprints. And blueprints is a language that's a high-level language that specifies what to do instead of how to do it. In other words, it provides a declarative infrastructure that makes it easy for AI to generate the app logic. Again, same kind of idea. Raise the level, make it easy for AI to generate. And Apex blueprints are succinct, understandable, and editable by humans. So that's how we're going to bring AI into this. We create a new language that specifies what you want to do, not how to do it. And we do so at a high level. And then we teach AI how to generate this. Okay? Now, earlier we saw a demo where, given a human language prompt, the AI can generate the data schema to store the data. What we've done now with Apex is now from a human language prompt, Apex GenDev, the AI assistant, can use an LLM to generate an Apex blueprint, and the Apex blueprint specifies and creates the full user interface and app logic to enter data, modify data, search data, and summarize app data. And what we're going to do now is we're going to demonstrate, Shakib is going to demonstrate how Apex AI assistant It's going to generate the app needed to query the athlete data just from a human prompt.
I want to show you how AI can enable Apex developers to build applications using natural language. From the app builder, I'm going to click on Create a New App using Generative AI. And for my prompt, I'll type in create a single page app with a faceted search on athlete events. Within moments, the assistant responds back, understanding my prompt, and suggests the appropriate page to create based on my data. This looks good to me, so let's click on Create Application. The AI response generated this blueprint for me, which I can then further customize on this wizard screen. Let's go ahead and create the application. Within moments, Apex generates the appropriate metadata and my application is now constructed. Let's go run the application and sign in. Now I see a faceted search on athlete events. Well, let's take a look at gymnastic events coming up. And I'm interested in my favorite athlete, Emma. And now I can see all the events that Emma is participating in.
All right, great. So again, the idea is we don't want to take AI and have it try to speed up what we're already doing. We need to meet it halfway. We need paved roads for AI. So we talked about doing that for data in a lot of ways. On the Apex, on the app development side, we're doing the same thing. We're meeting AI, we're creating infrastructure that's friendly toward AI, and that's really what's going to provide the benefits. You can't drive a car down a dirt road. It doesn't work. Okay, so up to now, we've talked about how GenDev simplifies the world for development and developers. Now we're going to transition to talk about how GenDev AI for data enables apps to provide breakthrough new capabilities for end users. So we're talking about developers. Now we're going to switch. How do we make the world for end users a lot better? And in particular, we'll talk about things like human language interfaces and human-centric data. Okay, so first of all, with GenDev, apps can now use in-database machine learning to make predictions about the future. And this is something that we've been working on for many years. So in the Oracle database, we provide over 30 in-database machine learning algorithms to help predict the future. And there's a lot of categories here. There's classification algorithms, regression algorithms, clustering algorithms, feature extraction, anomaly detection, association rules. We have a whole lot of, many categories of areas where we provide machine learning algorithms in the database. And by building these machine learning algorithms into the database, we make predictive AI simple to use for all apps. All you got to do is call the algorithm against the data that you already have, and it will produce the prediction. So that's step one, which is the traditional ML algorithms have been built into the database and made really easy to use. Okay. Also, with 23 AI GenDev, apps can now do things that were never possible before. So we can find documents, images, and other what I call human-centric data based on their semantic content rather than the words or pixels using AI vector search. So databases have always been able to store documents, store images, to store what I call human-centric data, but we've never been able to query it very effectively. So if you have a picture of someone or something, we can compare it to another picture and say, yeah, the pixels are exactly the same, but if there's any variation, it'll say they're different. And you can't find similar pictures. This is stuff that was never possible before. We could search documents by exact words, but we couldn't search them by content. So this is breakthrough new technology called AI vector search that has now been built into the Oracle database. So an AI vector is basically a sequence of numbers. They're called dimensions in the AI world. And these numbers represent the semantic content of a document or image or other data. And the way this works is that Oracle will generate the AI vector for an object using an AI model. So you hand it a document or image, you tell Oracle, okay, generate a vector for it. And then Oracle provides ways to store the vectors, new technologies for indexing these vectors, and new technologies for comparing these vectors to find similar objects. So you have a picture, you say, find me similar pictures. You have a document, you say, find me documents with similar content. So that's all that has been built into Oracle Database 23 AI today. I'll talk about how simple it is to use. It's just part of the product. There's no extra chargers. There's no extra anything. It's just a feature of Oracle Database. Okay, so with this new technology, businesses can run queries that combine this kind of new age vector search of things like images and documents with searching of business data like customers and products. So in this games app, for example, you can suppose you have a attendee that wants to come but needs a place to stay. Well, we can provide as part of the app a way for the attendee to say, hey, I want a house that looks like this to rent, and they can just upload a picture. I want it to look like this, but it has to be within my budget, and it has to be close to one of the venues that's in my schedule that I plan to go to. Okay, so we can solve exactly that problem now very easily with 23AI. And the query to do this is ultra simple and powerful. So the query is going to search a combination of customer data, the budget, product data, the homes that it knows are for rent, and this image data, the image that the attendee provided that says, hey, I want something similar to this. And you can see, you can do this in 5 lines of SQL. Combine the new AI technology with the existing relational data. So what this says is I'm going to select from my houses for rent where the rental cost is less than my budget, so that's customer data that we have in the database, and the location of the house is close to one of the events that I want to attend. So again, what events am I gonna attend? That's in the database. That's relational data that's stored in the database. And then I'm gonna provide these ordered by how close they look to the house image that the attendee uploaded. So we're combining this new vector search with relational data. And for enterprises to get the full benefits of this kind of human-centric data, documents, images, that kind of stuff, they really need to combine it with business data. So if you have, whatever, a customer support or something, you have to know who's the customer, what products do they have, what versions do they have, what's their account. All that's relational data. You need to really combine these things to really get business benefit from a lot of this AI technology. And that's exactly what we can do in Oracle Database, because we can store, we can create, store, and manage the vectors. We already create, store, and manage the relational data, and then we can join these together. And you can see here, this is very simple. 5 lines of SQL. The whole thing runs in single-digit milliseconds, the entire query. Super simple to do. Anyone that knows SQL can learn how to do this in 5 minutes. Super simple. Okay. And the other thing is, these AI vectors, this new AI technology, is just another data type in Oracle. So everything that we've done for the last few decades to make Oracle a mission-critical database that all runs with AI vectors. So whether it's scale-out clusters, parallel SQL, transactions, security, analytics, disaster recovery, all that stuff, it just works. And it's all mature technology because this is the same thing that we've been working on for decades. So this allows AI vectors to be used in enterprise apps any scale or criticality. So you can take your existing enterprise app, throw the new vector technology in there, produce new solutions, and it all just works, and it's all seamless, the same DR, the same everything, backup, recovery, it all just works. Okay, so that's AI vectors. We take this a step farther. We can now answer questions that are phrased in human languages while keeping strong control of the data. And that's, in the AI world, that's called retrieval augmented generation, where you're using an LLM along with the data in the database to answer users' questions. And this is a whole workflow that we've built into the Oracle database now. So the way the workflow works is you start by getting a human language question. So a user asks something in their own language, English, French, whatever the language is. And what we do in the database is we'll convert that question into one of these AI vectors. And then step 2 is we take that AI vector and we search the data in the database for things like documents or other data that relate to that. So we find documents, data in the database that relates to the human language question. We extract those documents from the database. We combine them with the question, and we hand that to an LLM, who then has the human language question, the relevant data, and then the LLM produces a human language answer to the end user. So this combines the data in the database with human language interface and an LLM to directly answer human language questions in a human language and produce a human language answer. And we've automated this whole process inside the Oracle database. And again, you can use any LLM you want. We interface to all the popular LLMs in the industry. Okay, so that's retrieval augmented generation. If you want to find out more, if you're interested in how other customers want to use this new AI technology in the Oracle database, tomorrow morning there's a session where you can hear how some of the leading enterprises, PayPal, Deutsche Bank, New York Stock Exchange, and Sony Pictures are going to use this new AI vector search and RAG technology in the Oracle database for their enterprise applications. So I invite you to join that. Okay, so I've talked about a few of the things we're doing for AI inside the database. There's a lot more. For example, we've interfaced with a lot of the leading AI open source frameworks, like Onyx is a way of generating the vectors. LangChain is a way of interfacing to this RAG. We've added AI capabilities to Golden Gate, so it understands vectors across different products. It can move them around. It can generate vectors. We've added vector support into Exadata, so you can scale the vector processing to any level. It'll automatically offload a lot of these searches into storage. We've added the ability to generate SQL from natural language with a feature we call Select AI, so a developer can express in natural language what they want, and we'll use an LLM of your choice to generate the SQL, a first draft of the SQL that then you can edit. We've added the ability to do the machine learning kind of algorithms that I talked about using GPUs, and there's a whole lot of other stuff. And there's a lot of sessions here at CloudWorld this week that talk about a lot of this new AI technology. So we're implementing all the leading edge AI capabilities, and we've released this stuff as of last May in Oracle Database 23 AI. And this is going to continue to happen. This technology is moving very rapidly. All right, so that's AI in the database, how we use it to enable new capabilities for end users, not just for developers. All right, and then finally, the last part of this talk, I'm going to briefly talk about some of the core database capabilities that we've added in 23 AI and how they help generative development. Okay, so again, the big picture is we're trying to generate apps, have developers use AI to generate apps. When you're generating apps, what you really want is for the app to be able to treat the database as a simple abstract building block without any limits. So it doesn't want to worry about things like functional limits, performance limits, availability, security, all that stuff. It just wants to focus on generating the app. And we want to take care of all the rest of that stuff inside the database. And that's really what we've been working on at Oracle. That's been our vision at Oracle for decades, and things that we've worked on. We spent tens of thousands of engineers' years building this technology, and we continue to build this technology. And our vision has been to provide a complete and simple database for developing and running modern apps and analytics. So by complete, I mean complete support for all modern data types. I talked about JSON, graph, spatial, relational, every kind of data, all the different workloads, analytics, OLTP, IoT, you name it, all the different development styles, and keep it all completely consistent, scalable, and available, so you don't have to worry about that kind of stuff. And then the second part of that vision is to take this complete converged architecture and deliver it as a cloud service that's super easy to use. And that's the vision of the autonomous database service, where we take the converged database, we run it on top of our industry-leading Exadata platform, and we deliver it as a self-driving, self-securing, self-repairing service. And another thing that's really important about this is it's everything that we've done for decades, and it scales down to even small workloads and small customers. So a small customer or a small workload can get the same level of security, availability, performance that, for example, a stock exchange gets today that used to be incredibly difficult to do. Now it's super simple. It's all automated in our autonomous database service. So what's new with 23 AI? We've really advanced our vision. There's a lot of technologies. I've already talked about many of the things in 23 AI, but there's a lot more. So again, a big problem that we've had for decades is long-running transactions that hold locks. Those have caused problems for years, so we've built a lot of technology for that. Akash mentioned True Cache, which is a truly consistent mid-tier cache. Again, this has never been possible. No one has ever built a truly consistent mid-tier cache where the data in the mid-tier cache stays consistent with the database. So we're delivering that with 23 AI. We've done a lot of work on preventing SQL plan regressions, which is actually a very difficult problem. There's a lot of work we've done to simplify SQL, make it more scalable. We added JavaScript as a stored procedure language. In addition to Java and PL/SQL, JavaScript is the world's most popular programming language, so we've added that directly into the Oracle database. We've also done a lot on this infinite scalability and availability that we've been working toward. There's another feature Akash talked about earlier, raft replication. It's a new kind of replication that keeps data consistent across different databases in real time, and it enables single-digit second failovers whenever there's a problem. So we built that into our globally distributed database, which has many enhancements in 23A also. We have a new architecture for Exadata, new software architecture called Exascale. And the idea of that is it will enable any app to grow or shrink. So now, previously you had to have a fairly large configuration to run Exadata. Now we can shrink Exadata in our cloud down to 2 cores. So a simple app that just needs at least 2 cores can get all the benefits of Exadata. So this is a major new architecture. It also greatly improves the snapshot capabilities of Exadata. So that's another big thing. And another thing, if you follow the analytics world, it's a very big deal to store data in object stores. And there's this new thing called Iceberg, which is a way of sharing data across multiple databases. So we fully support that now. So there's a lot of new capabilities. And again, there's sessions at CloudWorld this week on all these topics. So I invite you to visit those. Every single one of these is a huge development. 23AI is really a monumental release. It covers so many different really breakthrough technologies. Okay, so what are the key takeaways from today? We've entered the age of AI, so we need AI-centric enterprise development infrastructure to gain the full benefits of AI. And this is something we're thinking about. We're really kind of unique in saying, hey, we have to change the way we do things to meet AI. You can't just expect AI to just solve every problem by itself. And the big things are we've developed infrastructure that enables apps to be generated as a collection of independent, trustable, evolvable modules. And I've talked about how that works. That make generated apps understandable by humans and editable by humans by emphasizing succinct declarative languages. So we think declarative, to the extent possible, everything should be declarative. And I talked about how we automate a lot of these enterprise capabilities like scalability, reliability, consistency, and security that are necessary for enterprise apps. You can't mess that up if you're implementing an enterprise app. So we've automated that to make it much easier to generate apps. The apps doesn't have to worry about this stuff. Also, the infrastructure that we built also enables end users to benefit from AI. So it enables users to predict the future. You can now create human language interfaces to databases, and you can query human-centric data like documents and images by their content. So all these technologies are really revolutionary technologies that really are going to help accelerate our path to the future. So again, cars needed paved roads to achieve their full potential. You can have the world's fastest car. If it's driving down a horse trail, you're not going to get much out of it. And GenDev is this infrastructure that we've designed to be AI-centric development infrastructure. We've introduced this in Oracle Database 23 AI, and the idea is to accelerate the benefits of AI and mitigate the risks. Okay, so everything I've talked about, this is not a vision for the future. Everything I've talked about is here now, and all of it enables dramatically faster and more productive enterprise development. So I invite you to go to our demo grounds, attend our sessions, and I encourage you to learn how to generate to innovate using GenDev starting today. It's all available now. This is the future. We all got to get on board or we're going to be left behind. All right, thank you very much for joining me today. I hope you enjoy the rest of your CloudWorld.